Hey, everybody out there. Welcome to Start Left, Not Left Behind, Building Bulletproof Containers from Day Zero. This webinar here for May 28th, 2025. We're happy to have you. We always like to know where people are coming from in the world. I'm Dwayne McDaniel. I am your host for today, and I am located in Chicago, Illinois. But we love this to be interactive. We want you to ask questions. This is your time to learn, and we want to learn with you. So feel free to use the chat. And that's the first question we're going to ask is just tell us where you're out in the world. So, hey, Eric, Dallas, Fort Worth, the areas, we got Uganda. So while everybody's chiming in there, this would be a good time to introduce the other person you see on screen. Adrian, where are you at in the world?
Hi there, Dwayne. Thanks for having me. I'm Adrian Mouat. I work at Chainguard as a DevRel engineer, and I'm currently based in Edinburgh in Scotland.
Excellent, man. So we are here today to talk about this idea of shifting left and starting left, sorry. And I got to ask though, for those out there that aren't familiar with the term, it can be confusing because when we talk about development these days, this is the image. This is the de facto, this is from Wikimedia. This is the de facto what DevOps is. This is how we build stuff today. So where is left in this picture is the question.
Yeah, it's a loop, right? It keeps going around.
But what we looped was the software development lifecycle. This is a well-established thing. This comes from the old days of waterfall. You do this step at a time, and then at some point you do the testing and integration. That's step 5 here. And that's the left that we're pushing. So it's not the loop, but it also, maybe it is. Maybe we're starting to think about security all the way wrapped around that loop. So every step of the way. Well, one of the big reasons we went to that loop was this concept of containers came around. Now, I don't know if everybody's out there been developing a long time, but I remember the good old days when we would just FTP up a code base and hope it worked. White screen of death is a real thing I've lived through many, many times in my days learning. But now we live in this world of continual integration, and what we build in that is most typically containers. Container infrastructure took over. Like there's a reason you know the name Kubernetes. There's a reason Docker's a thing. You can take the image you make, run it, drop it into a container, and then drop it into a million more containers and scale like crazy. Now, there are a few security concerns around these containers, and that's what we're here to talk about today. Like how do we solve these problems? But the biggest problem I'm concerned about, it shouldn't be a surprise out there that you're on a GitGuardian webinar, that my biggest concern will be the fact that they leak secrets like crazy. And it's not just that they leak in the container itself, but throughout the entire process. And we know secrets leak because, well, you've probably seen this report from us, the State of Secret Sprawl report. If not, you can go, we'll drop this link into the chat here in a minute. This is how many secrets got leaked onto GitHub in public just in the year 2024. Like we looked at all the commits that hit GitHub public, and this is what happened. So we know this is a growing problem. It's a 25% increase over previous year's report. So we keep leaking secrets. But relative to this conversation, part of that same report is this fact that we looked at basically all of Docker Hub, a public Docker infrastructure, and you go read the report to get the fine-grained details, but we found over 100,000 valid secrets in those containers. That's not really great. But that is one of the many, many things that can go wrong with containers, right?
Yeah, that's true. But that screenshot makes me wonder about the 29% of Google. Is there something like Google Cloud's documentation that means that they leak more?
You know, I don't
I
know.
probably shouldn't pick on Google Cloud. I don't mean to. They're usually pretty good.
I'm not trying to pick on them either, but I'm gonna go get the state of state speakers report. I'm gonna drop this link in there. I should have had that ready. We're doing this live, everybody. Now you can go read that report yourselves and dig into that number. But as I said, this isn't the only problem out in the world of containers. Like, and you've put together a pretty interesting list about that.
Yeah, so this is what I've been working on recently, which is the container harden priorities, or chip spec. And you can go and grab a copy if you scan that QR code, or just go to chips-dev, that's CHPS-dev on GitHub. And I guess you'll reach that via Google fairly easily as well. And so the chip specification basically is a bunch of identifies a set of areas where you can improve or think about improving the security you've built. So the criteria split into 4 areas, and I've used chili levels to indicate the level of difficulty here. So we got pimiento peppers for things that should be relatively easy to build or fix that you can go and do today, and all the way down to your ghost peppers, which would take a bit more to fix, a lot more effort involved there. Now, I was saying earlier to Dwayne that I would never eat a ghost pepper, and Dwayne tells me he eats them every day.
Not every day, but I do use them in my hot sauces, and I love them. If you're not trying to ghost pepper, don't be afraid. If you eat a very small amount, they're really fruity and juicy. But I think I agree with you. They are very spicy. You have to be very, very careful with them.
Yeah, don't bite off a whole one. Use it appropriately. Cool. Yeah, so chips has 4 main areas, which are minimalism. So that's kind of how much tooling is there in your container image. A larger image is going to have, or images with more tooling are going to have a greater attack surface. So there's more things in them that attackers can poke at and will potentially have vulnerabilities. And also, they also have tools that attackers can potentially use in their own attacks. That's sometimes called living off the land attack. Yeah, so the easy level here is just using a smaller base image. With tougher levels, doing things like removing package managers and shells. Then there's provenance, which is basically the ability to say where or determine the provenance of things, the origin of where your container image came from. But it's not just do you know who created the image, it's also do you know what's in the image and who created those things. And that gets to things like SBOMs or software bill of materials. Then you've got configuration and metadata, which contains several different security related criteria. But note the first step here, that's ensuring that you don't leak sensitive information in images, which is exactly your point. Of all the things in this specification, that's probably the most critical one to get right. And of course, that's where GitGuardian really shines, and I'm sure you could do a demo of that in a minute.
Mm-hmm.
Other checks do include things like making sure your images aren't running as root, and you support annotations and things. And finally, you can look at vulnerabilities. So that's, well, I guess a lot of you have probably used a tool like Trivy or Sneak or Gripe, and you got results back. And ideally, we'd all like to be able to say, hey, if my image has any vulnerabilities, let's not deploy it to production. But in reality, you can't do that because you'll probably find that your base image, the image you build on top of, has vulnerabilities. And it kind of makes things like that really difficult.
So thanks for walking us through that. And that makes perfect sense. And I definitely agree. Shouldn't have secrets in your images. But I did have a couple questions off of here. So under jalapeno, like in provenance, we start with known from a trusted source. Hopefully that is everyone's base of operation. Like, you know exactly where you're pulling from. You're not just pulling from the wild west internet, right?
So I'm mainly thinking of like, in the Docker Hub, you can use a Docker official image, and that's a trusted source. Docker official images, like you believe Docker built. And the same with Chainguard images, you trust Chainguard to have built them. But if you go into the Docker Hub, you also find user images. And those things can be anything, and they can be really old, or they can, in some cases, be malicious. So that's kind of where I'm going for with trusted source. Make sure you trust the organization that you're pulling that image from.
So underneath that is like verified. Is that download by a signature or something? That's okay, just abbreviation there. So why is signatures and checksums important?
Right. So in a lot of Docker files, you'll see people doing things like wget or curling, downloading some tooling or data or software, something like that. And it's important in that stage to also check that you're getting the thing that you expect and that nobody's changed it on the server or it's not been modified in transit. And the way you can do that is, well, a very simple way is by using a checksum. So you create you download it, you check it, and you create a checksum for that data. And then the next time you download it, your Docker file will check that it still matches that checksum, so you know it hasn't changed. There is a smarter way to do that with signatures. So if people sign their downloads, you'll find a lot of people use GPG to sign release artifacts, for example. You can store the signer's public key signature and use that to verify that the artifact was signed by them and definitely came from whoever signed it. And that that means that you don't have to update your checksum each time.
And just curious, like, what's the difference between a signature and like that next one down, like penning an image to a digest? Like, what was that difference?
Well, there's actually a little bit of overlap there. That's more on your from lines. So in your from line, you can do, from Debian. If you're using a Debian-based image, you do .from Debian, then @ and this big long SHA hash, and that will give you an exact version of the Debian image. And it's very much like checksum, because that's effectively a checksum of the contents of the image that you put in there. So it only will refer to one specific image. And so it doesn't get, you know exactly what you're using each time. And that's, great for reproducibility in particular.
So the last parts, we don't need to go all through that, but like, this really is a compliment to Salsa. And you say that in the article I linked to out there as well. And let's be honest, did you backfill the acronym here to make chips and salsa?
Yeah, I think we did. Yeah.
That
wasn't me. I blame Distin Kirkland.
No shame there. I mean, Guac is another awesome project out from the Cloud Native Computing Foundation, and that's, I think, why it's named Guac. Guac and salsa go together, and now we got chips.
Yeah. But I have to say though, like in Scotland, like chips is French fries. Mm-hmm. So it just confused me sometimes. But yeah, Dustin meant when he said chips, he meant like tacos.
Tortilla chips. But for those of you who might be new to this concept, salsa is the supply chain levels of software, supply chain levels for software or artifacts. It is the CNCF proof, that's the provenance attestations, like this document that contains all the known parts and how we put it together. And there's multiple levels to that. So that's really what I'm seeing the difference between Nagamon and Ghost is the difference between like salsa level like 1 and salsa level like 3. Does that line up about right?
Probably. I didn't intentionally align it to salsa levels, I will say that.
Okay.
But yeah, reproducibility is a big thing in salsa. I'm not sure of full reproducibility. I think that's coming in the next update to salsa. They certainly talk about it. But yeah, that's a fair point.
All right, man. Well, thanks for sharing that with us, and hopefully everybody goes and reads. This is pretty awesome. So we actually had a question in here, and I want to take a question live just so we catch it in here. To be clear, what are the most overlooked security controls or misconfigurations in container builds that developers unintentionally introduce at day 0? And how can we catch them before CAD pipelines even run? Maybe we should answer this question later, because I think we're going to answer your question as we go through the rest of this, Miriam. But thank you for the question.
Well, I guess one thing is, I think your demo will catch one. But I think the root use, like I would try to avoid running your images as root. And that's, you can put checks in. And Kubernetes, you can put a check in to say no pods can run as root, for example. That's probably the biggest simple configuration thing. One thing I would like to see people do a lot more, sign their images. Like you'll find vendors like Docker Hub and Chainguard sign images, but I don't always see it happening within organizations. So that's probably 2 easy ones that I would say make sure you do.
And I just want to say, again, I'm a developer advocate, as are you. This stuff is hard to get exactly right. What if the Kubernetes configuration is run not as root is the actual thing? Is that true, or do we set that as true or false? That's like, now we're in double negative land. Yeah. So it's that level of like, it's well-intentioned words, but I mean, developers got a lot on their plate. So we have a question for you in the audience, and we want to know what your biggest concern is with containers. I'm going to publish this poll right now, so you'll be able to interact with that in the should be able to see that live and submit a vote there, and we will come back to that and talk about that in a bit. But thank you for that. But let's move on to talking about, well, actually to answer Miriam's question. Sorry about that. This idea of starting left. We really need to check security throughout. If we were talking about the old days of waterfall, that straight line, and testing is like step 5, then really we're going to test over here at, once the container is built. It's a good time to check, double check before you push it out there. But you can also catch things when the container itself is being built, and that is the CI/CD pipeline. But if there's a security concern that's going to be introduced, it'd be better to catch it a little earlier. And that is when the shared code base comes together on GitHub or GitLab or Bitbucket or where have you, whatever your shared repo is. But this idea of shifting left, we've really been talking about before it gets over. But I love the idea of starting left. I really do love this, because if we build the security tooling in from the very get-go, before you even make the commit, wow, what a time to catch it, because that's the easiest time, maybe not the easiest place to fix it, but it's definitely the best place to fix it. It is going to take you out of your workflow a bit to say, hey, I need to go fix this thing, but that's better than having a new bug ticket open. That's better than coming back, breaking production, introducing a security issue that gets through and causing a breach, spending the extra few minutes to do it right. But that's what developer tooling comes in. That's where Adrian and I are going to talk to you about next and really answer that question a little more fully, Miriam. So let me go to the next slide here. And it's demo time, everybody. So I'm going to show you how GitGuardian can help you specifically with the problem of finding those hard-coded credentials and stopping that problem before it starts. And then Adrian's going to talk about the other areas of container security. So let me flip over to the world's favorite code editing tool, VS Code. We have built a VS Code extension. And what it does is, well, let me actually pull up the terminal. We have this tool called ggshield. Ggshield is our command line tool. It extends the full power of the GitGuardian platform and our ability to find hard-coded credentials in any arbitrary text to your IDE. This is what this powers this under the covers. So it's no magic. It's no special like wizardry here. This is just straight up CLI awesomeness. But we built it at a level that we can catch things on save. So I have this, I've loaded in a fake, and just to prove it's fake, I'm going to make one up here, a fake AWS client secret pair. And then, because you can't see me hit my keyboard, I'm going to go ahead and hit save. Normally I would just hit Command save. And wait a minute, I got GitGuardian secret found. Now we think a lot of the times that people include a hard-coded credential, it wasn't intentional and then saying, well, this is how I want it to go to production. It is, I'm debugging something. I just needed to rig it up to make sure it worked. Does this endpoint even work? Will it authenticate? And then you have 30 files open. I only have a handful of files open on my machine. I still can't tell you what every tab is or what I've changed in any of them. But now I have a warning that says, hey, you've done this. And here's exactly where it is. You've done this, and this is exactly where it is. It's highlighting up in my code editor. So now I can go in and fix that. Now I understand not everybody uses VS Code. If you tell us what tools you want us to extend this to, we were happy to work with you. We'd love to work with you on that. But let's live in a world without this for a second. So
this is VS Code only at the minute. Is that correct?
At the moment, this is the VS Code extension specifically. So I'm going to go back in and I'm going to disable this thing, restart extensions. And here we go. I have no problems because even though I've saved this, I'll make a new one just to say I made a new one. Let's see, we'll change that to enough. And then I'll hit file, save again, and nothing. I got no problems. And that's to say I'm in a hurry. It is 2 o'clock in the morning and I am doing my best to get out of here. I've been coding for a day and a half, and I'm going to do the big thing you're never supposed to do and just hit the self-referential dot or an asterisk and say, just stuff it all in the index. Just let's do it. And now I'm going to hit my git commit, commit -m. And now if, demo, which is the best commit history of all time message. But I'm not worried because I have also used ggshield, our command line tool, at the pre-commit level. So if I show this in action, it found something. I found a secret. It tells me what line it's on. It tells me some more pertinent information. If I look at my git status, let me make this a little bit bigger for you out in the audience. There it is. Like, this has been added. It's still in my git add. It's still in the index, but the commit hasn't happened. This is awesome because the commit is the permanent record. Your index is your working, what you're working in. Like, I can modify my index all day long and none of that will hit my permanent record. So I can fix this right here and then literally shifting the whole problem and fixing it right now. Now, this message you see here is completely customizable. That's what we allow you to do. This is one I built because it's a demo and I like owls. So that is how we are helping people shift left. So if I go back to my slides, excuse the slide, shift left. So we are best known, I think, for our public monitoring. That is, we've been doing that for a while now. And also our secrets detection at the code base level at in Jira, Slack, all your other data sources. People love our hunting tokens, that early warning sign. And now we're getting into the world of NHI governance. But driving all of this is the idea that's empowered developers to do their jobs faster and safer. Because if we can eliminate the problem from ever making it to a shared code base, then there's nothing to detect. Their governance becomes pretty trivial if you've done it directly, or you've done it correctly from the get-go, which again is hard. This is not something, if it was easy, developers would just magically have done it already. And I'm always going to advocate that we need to make developers' lives better, not worse with tooling.
Yeah,
So
that's awesome.
That's how we're helping. Hopefully that answers the question fully for my side of the thing. But now, Adrian, before we actually go on, I did have a question for you, talking about developer tooling while we're making a transition here. Go publish the poll real quick. Here we go. Publish the poll. Do you integrate security tools into your workflow already? So you can go ahead and answer that one. And before that, I just want to go back. What concerns you the most about container security? CVEs, no shocker there. It's the number one answer, 38%. Leaked secrets coming in second. Good. I'm glad that's ranked second and not last on the list. 0 days and then provenance. 0 days concern me. They concern me a lot because, well, they're everywhere. We don't know about them till we do.
Yeah.
But you are going to help us get to a world where, unless it's a crazy out there 0 day, you've done everything else right, you're going to be as secure as you can. And that's the bulletproofing, right?
Yeah, that's right. Yeah, so definitely the 38% of people that are concerned about CVEs, I definitely hope I can help you here. So we called this talk Bulletproofing Containers, which made me think of your old school shoot 'em ups. I know you still get a few. This is a picture from a classic one. I do have to explain that Inky was not originally there. I did add that. I know it's a very good Photoshop job, but
I thought it was actual gameplay footage.
Yeah. So a bonus points to anybody that can name this game. I don't think there's any prize. I don't have any prizes, but yeah, definitely kudos if you can actually tell me what game this is a screenshot from. Anyway, I'm going to jump straight to the demo. So when I'm trying to explain the sort of benefits of Chainguard containers, what I normally do is, there we go. What I normally do is take them to this page. This is the images.chainguard.dev page. You can go and reach this yourself now. And I'll search for a sort of common container. So let's say Redis. And this gives you a page with some more information, but I can drill down to this comparison page. And this comparison page shows me the Chainguard image on the left and Redis latest in the Docker Hub on the right. So you can see there's a few differences here. One, our image is only 11 megabytes in size compared to 47 megabytes for the Docker official image. But more interestingly, there's lots less CVEs. So there's only 4 CVEs currently, the Chainguard image, but there's 21 CVEs in the Docker Hub official image. And if you go and we look over time, we can see this is, an unusually high number of CVEs for the Chainguard image, but it's actually quite an unusually low number for the Docker Hub official image. And I can drill down a bit more into the CVEs as well. So if we go to the vulnerabilities tab, that gives me a list of those 4 CVEs. Well, this one appears twice because it affects 2 packages, or 3 CVEs, I guess. The 2 low ones here, we're waiting on a fix from BusyBox. So there's no current fix that we can pull in for that. That's a slightly different case with this libSSL one. Now, in both cases, these are quite, and it's the case for a lot of CVEs, they tend to be things that are unlikely to hit you. So like, for example, these low ones are all to do with terminal escape sequences. So somebody would have to craft a terminal escape sequence and somehow get that into tar and busybox in your container for this to be effective. libsSL is always a little bit more worrying, though. In this case, it is a very specific vulnerability. So you'd have to be using trusted certificates and rejecting them for a particular use, which isn't something you're going to be doing inside the Redis container. So it's not really of worry in this case. That being said, there is now a patch available upstream for this. So we're currently in the process of applying that fix to our version. And I did talk to the team, so there should be a build out today, tomorrow, that has a fix for this vulnerability. And so these two CVEs should go away in the next day or possibly 2 days by the time the scan gets updated. I can, oh, look. So this happened literally, yeah, just before we started this webinar. So we've issued a fix. So we said, hey, this is fixed.
Wow. So it seems like not all CVEs are created equal then. Like, is that a fair assumption?
Yeah, it's definitely a fair assumption. So, I mean, some CVEs can be nonsense, and really probably should never have been given like a CVE ID. But that's a system we have, and people are kind of incentivized to find and document CVEs. And in a way, that's a good thing because we find more things. But a problem it creates is that you get, Docker, you get sort of base images with hundreds of CVEs. And then you're in this issue of like, well, if there's 100 CVEs in this image, what can I do? You're kind of stuck because you don't have time to go through each of them, right? You can, it's almost paralyzing because you want to be able to say, don't deploy to production if there's not any CVEs that I haven't said are okay. And it kind of makes that extremely difficult. An answer here is, well, consider using Chainguard because there's only 4 CVEs and that's an unusually high number. And you can go through and say, well, okay, this busybox CV isn't going to affect me, and this libsSL CV isn't going to affect me. We're good to deploy. So that's a difference it makes. Yeah, let me go on to. I'll show you another one briefly. It's just to keep going. So if we look at the Nginx comparison, we have the same libsSL CV, but this image does not include a shell, so there's only 2 CVs this time. The alternative I'm comparing to is the Alpine version of Nginx. Now, I have to say that Alpine images are pretty good. Like, they tend to have less CVEs because there's less software in them than the Debian-based versions. You can also compare to the Debian version, and you'll see that the CVEs jump up quite a lot. So there's actually 49 CVEs there compared to the 2 for the Chainguard image. And you can see it's normally been 0 in the Chainguard image.
Is that just partly an artifact because Debian is bigger image than Alpine? And like, is Alpine already like trying to go minimal, or is it more security focused? Like, what is that difference?
I think it's a bit of both. Debian, it's to do with update frequency is one thing. So like Alpine maybe manages to update stuff a little bit faster, but a lot of it is just the image size. So you can see like this is 69 megabytes for the Debian based one. And if I go to Alpine one, it drops down by 40 megabytes. So it's just 40 megabytes worth of stuff there that, isn't in the Alpine image and therefore can't have CVEs. So I think that's probably the major difference.
I know.
Oh, Eric, who, full disclosure, works at Chainguard, actually got Xenon too. And yeah, I believe it was the Amiga screenshot. It was also on Atari ST and NES and so on. So well done to Eric. I do have to say, you're showing your age here because this is, I don't know. We're talking about what, 1989, 1990, something like that.
To be fair, in full disclosure, I know Eric as well from the tech community, and we're both big fans of the 8-Bit Guy, which is a pretty awesome YouTube channel about old computers and old games. So, not a shocker that Eric got that, but everyone else, that's the answer too. So I'm gonna go back to our poll just for a second as I'm sharing screen here, and looks like more than half the people that took our poll has said that they are in fact using automatic, that they are automatically running developer tools in their workflows. 57%. Thank you very much for doing that, everybody. That's making the world a safer place. Unfortunately, the second answer was no. And then people running them manually, better than not running them, in my opinion. And then there's some person that was honest, is like, well, I don't develop. So thank you very much for voting, everybody, and being part of our poll. We always like to know what you're all thinking out there. So
cool. So I'm going to demo this with a chip score. So chip score is a tool that we wrote to automatically check as many of the chips criteria as can be sort of easily automated. So here I'm running the chip score on the Nginx image. This is the Nginx image from the Docker Hub. It's latest version, so based in Debian. And you can see sort of some of the differences or things going on here. So it's quite a large image. It's over 40 megabytes. It has a shell. It's also stopped, so I'm getting slightly worried. I might have to go back to slides. Anyway, we'll find out in a minute. Oh, there it goes. Yeah, so it's failing some of the minimalism criteria. It's quite a large image. It has a shell, has a package manager. My score hasn't found an SBOM. I think there should be an SBOM, so that could be my problem with the score, to be honest. Otherwise, it does do pretty well with the provenance criteria, is a Docker official image, and they do sign their images. Files with elevated privileges found. So that's things like sudo, like things that need to run with higher capabilities, such as root privileges. The binary itself that starts up as also runs as root. So the Nginx image from Docker Hub starts as root. And there's also a whole bunch of CVEs, as we saw before. So overall, this doesn't get a great grade. We can compare that to the Docker, the Chainguard version. And so you can see it's not just CVEs that we worry about. We do worry about other stuff. Again, it's a much smaller image. There's no builder debug tool, and there's no shell, and there's no package manager by default in the Nginx image. Yeah, we do have all the provenance data. We don't have files with elevated privileges. So there's no like sudo or whatever's causing that to fail in the other image. It doesn't start as root by default. And we've got annotations, SBOMs, and we do a good bit better on vulnerabilities. You know, in the past, we've definitely got to 0 vulnerabilities. So I'm a little bit sad it's not 0 today, but never mind. And I can quickly run it on Redis just to show you that as well. So this is Redis from the Docker Hub, again, looking at the Debian version or latest version. And again, you know, it's quite a large base image, and it does have a shell, does have a package manager. And this is open source, by the way, so you can go to the GitHub page and you can run this yourself. It is easiest to run. Oh, got a fail there. It is easy. Look, I hit my pull rate limit. This is what happens when you get kicked out of captains. This is, what was I going to say? Oh, thought through me. But yeah, again, it passes all the provenance criteria. Oh, this one it has found an SBOM. Yeah, so interesting. It's finding the SBOMs in some Docker official images and not other ones. What I was going to say was, if you try and run this yourself, it's easiest to run the chip score from a Docker container, which has all its dependencies in it. I am running it here just locally. And yeah, it's also running as root, has elevated privileges and CVEs. And we can compare that quickly to the CGR version. You can also see I've got some badges that come out the end, so you can also put those on your GitHub pages or similar. I am still working on the action. There was a people, an external did contribute a GitHub action to the project, so you can set it up to automatically run the chip score on your CI/CD. And yeah, you can see like our image does or the Chainguard image is a good bit better on all the scores. So we get a better overall score coming out here. Yeah, and so yeah, you can get badges out, but you can also, if I specify -o HTML, oh, this will hit my pull limit again. But if I specify -o HTML, it should give me an HTML report out, which is something I'm kind of working on at the minute. And when well, I guess I'll stop sharing once this comes out, and you'll see like what this looks like. But that's the HTML. It's all, just within one file, so you can just paste that into your CI/CD and get a report stored there. Okay, so I'm going to stop sharing, and we can go back to the slides.
Awesome, man. Thank you very much.
Maybe I should go to the questions. I think there's a couple of relevant questions, maybe.
Yeah. We can do that while we're. I'm resetting up the.
Cool. So there was a couple of ones. Yeah. So Aditya, you asked, what are the best practices to make an image secure and small in size? So small in size mainly comes down to your base image. And so if you look at using things like a distilless approach and multi-stage builds, that's how we really go for small in size. And if you go to Chainguard Academy, so it's edu.chainguard.dev, then you'll find lots of guides on how to use distilless images and multi-stage builds to make your container small in size. And that's really hitting the secure point as well. The only thing about security, I would also say, is try and keep updating things. And obviously, apply the other things from the chip specification. I really feel like just constantly being on top of updating things and having some automated flow for doing that gets you a lot of the way in security, at least in terms of CVEs. What other ones? There's something about philosophy RMF. What's RMF, Dwayne? Can you help me?
RMF.
Jeremy's asking, how would this philosophy be applied RMF? And at which phase would you begin this process?
Yeah, if you could answer us back in, Jeremy, and let us know. I'm not sure what that phrase means. While he's answering there, I did realize just now I should have explained how we got to that Docker secret count that we did earlier, that I showed earlier. And to do that, I had to pull up Docker. That's what I was doing in the background. But that's part of ggshield, is we can run a secret scan the same way that you just ran your tool to do this set of checks. We can do that directly on any image. So it can do the pull. Yeah, obviously, updated things. I don't know why I picked PyTorch, just because I did.
It's a huge image. You shouldn't have picked that one.
I shouldn't have picked that one.
3.6 gigabytes.
Well, this could take a while, everybody.
That's okay. I can answer a question in the meantime if you like.
Yeah, let me go pull Juice Shop, which is much smaller. Except Juice Shop is going to blow up. I'm almost there. I got a really fast internet connection.
You're doing well.
I'll just I'll let it burn. We'll answer the question while we're going.
Okay, let me answer Shashi's question. Sorry if I'm butchering people's names. I apologize. So the start left and Chainguard provides a base image for Redis with small size and low CVEs. But if I need a custom image, how can Chainguard help there, or is it only useful for basic images? So yes, we have application images like Redis and Nginx and so on, but we also have base images. So we, like, say you're writing a Python application, we have a Python base image and we have a Java base image, or JDK and JRE base images. So what you can do is create a multi-stage build. And what you'll do is you'll build your application in one step, then you copy the application on top of the runtime image, like a JRE or Python image. And that's the way we would help there. So you'll have a base image that you put your application on top of that's like low CVE and secure. I hope that makes some sense.
I looked up RMF, and that's the risk management framework. I'm assuming you mean NIST's risk management framework. And that's actually a really good question.
Okay.
How does this fit? So I am not familiar intimately with that. I probably should be. I know the concept, but I can't speak intelligently to exactly how it aligns, but it does, because it's basically, how do you protect your cyber supply chain, and how are you doing risk management? And that's what Salsa set out to solve. So if you're following these practices, it's going to integrate, because that's how you implement, because the framework isn't a tool. It's a framework. It's a set of structured processes that you put into place. So yeah, if you're going after this and you are starting with Chainguard images, or you're starting with minimal images, and you're starting with images that Hey, almost there, almost there. Starting with images that come back clean when you do a pull and finally actually run the tool against it. That would align, in my opinion.
I'm worried you're about to run out of disk space right at the end.
If that happens, then I shouldn't have done this, but we're almost there. We're almost there. My poor processor on this machine has been so abused today on presenting things. All right, we're almost there. Then we actually do the scan itself. And nervously waiting. And hopefully this comes back with 0. If this comes back with an image, then we'll have done this live and didn't disclose properly to PyTorch that we did this. Because it's got to scan a 3 gig image. Yep, I should have picked a different image, everybody. Sorry about that. I literally just grabbed PyTorch because it was the first one I thought of that I can remember off the top of my head. All right, we'll come back to check on that later, but that's GitGuardian scanning the image itself. Well, we're going to start running out of time here, and you don't want to stop. We'll just watch a terminal spin. But that's the idea here. Like, if we can put security into every step along the way. So this actually completes the circle, because you're talking about starting over here with the images. So like getting like the right image from the get-go, but the image is the output of a different system that also you can scan that piece. So that does bring us back into the full picture. That actually does turn this into the complete cycle. And now we can see that we've shifted left, but really started left, but really we started security and really done SecOps, which in my opinion is just saying you did DevOps correctly. Like, you've done security correctly. Now, we wish we could say this was all just, you could throw the right tool at it and that's the only thing you need to do to be secure out in the world. But in reality, like any other project, anything else you do in life, it's going to take the right people following the right processes and using those correct tools. Like the risk management framework, having that discussion, having the right documentation of how do we secure our teams? How do we work together to do this? How are we empowering the developer and raising awareness? This is step 1 of this journey. If you're brand new to all of this, congratulations, you're doing the right thing because you're raising awareness about this yourself. And now you can raise awareness with other people. You can start conversations, create the right processes, figure out what are the right tools for you to use. Good call. I got a typo on here. I will fix that after the fact. Yeah, it is managing. You see, this is like what I'm saying. It takes a village to do anything. So I appreciate that, actually. So let's go back. I hope it's run now. Nope. I did not plan on doing that part of the demo. That is why the demo gods have frowned on me, because I didn't dry run that with you, Adrian, and everybody's getting to see that.
Well approved.
But open it up officially for your questions. So thank you very much, everybody.
Yeah, I think we've got a few questions. I can start. Well, I think this seems quite nice. I'll try using this feature. So we've got asked, observability is important to a container's life, and we've not mentioned anything, and that's fair. Observability is definitely very important. From the chips spec point of view, like I intentionally focused on the build stage. I am considering like doing a second part to the chip spec, or second spec that focuses on the runtime stage, which is exactly where observability would come in. And yeah, it would be vitally important to make sure, that it's up and running, that's functioning correctly, that's login, etc. There's a lot you can talk about there. I don't know if you've...
Oh, sorry, I was answering a different question.
Right. Oh, sorry, you've been typing away. I don't know if you have anything else to say about observability.
I was asking a different one, but important. Yeah, absolutely. Observability is important. And that's actually the basis of our entire movement into the non-human identity space, is to give you that observability across your secret landscape. We have historically been the best at finding hard-coded credentials where they're not supposed to be out in the world. And now we're able to help you inventory and get observability into all of your secrets, no matter if they're properly vaulted, improperly vaulted, thrown in an ENV file somewhere in your file system, thrown in SharePoint. Someone, for some reason, shoved the whole thing into Confluence, just like hard coded them there. Yeah, we can find all those now. But if you don't know about them, you can't protect a thing. And that goes actually back to well, NIST in general, but the threat detection. I'm thinking about threat detection a lot. Is if you don't know it's there, you can't protect it. That's threat modeling. You have to know it's there first and know what you're working with. Raphael out in the chat gave us a nice little framework, which another circle. And now that I've seen it, yes, my brain snaps back into function. Of course I know this. I just never referred to it as RMF. So that's what threw us.
I thought so I was trying to tee you up there. I thought you were going to talk about this, how to deal with public images malware checks.
Oh, sorry. I was answering the wrong question.
No, you weren't. That was me. I assumed you're going to segue into that.
Well, actually, I was answering Shannon's question. Will these slides be shared? That's a very simple question. They can be made available to you, but the recording will be made available to everybody that was on this call. You can actually come back into Livestorm on the link, and for a limited amount of time, see it there. But we'll also put it on YouTube and email it to you that way. And then if you email us back, we will send you the slides. Happy to. But no, how to deal with public images, malware, crypto checks. Does CHPS check that as well? Well, that's a question for you. You're the CHPS guy.
So there's not too much in the CHPS spec about it. What I would say is that it largely comes down to trusting, using trusted images. So I would say that's a point that largely covers this. You absolutely could add something to your CI/CD to sort of scan for this, and I would recommend that. And that's what we do, and something we're really kind of building out at Chainguard. So at Chainguard, we're constantly building upstream projects. That's what we do. We're really fast at building the latest release from upstream projects. And that's one of the reasons that we're able to get security fixes out so fast. But as part of that, we're also looking into how can we make sure that the latest build does not include malware? Somebody hasn't taken over the GitHub repo and inserted malware, for example. Now, one thing we do is we always build from source, or we're trying to always build from the source. So we're not using tarballs, we're going and getting the actual Git source, for example. And that can cut out a certain subset of attacks where people have managed to replace the tarball, but they haven't managed to change the Git source because there's more eyes on that, for example. But yeah, overall, there's nothing in the CHPS spec specifically about that, but I would recommend running some sort of check. And there are stuff you can get out there to check in the same way that GitGuardian does to check your stuff in CI/CD.
See, if you're running small with image, it actually does run. So I looked at the ggshield for our images, and we don't have any, but that's complete the thought. But that, yeah, it's a good question, but simply don't have anything other than don't put your secrets there. Sorry. All right.
Sorry, I'm just reading this question. I do have a lot of Docker books. To be fair, one or two of them are mine.
Oh, and we Adita, did we already answer the best practice of making the image secure and small in size?
I think it did. I wasn't using the tooling at that point, but we did, yes. Basically, I'm saying using where was that when I click it so it goes away?
Start live.
That one. Okay. Yeah. So basically, just to reiterate, I was just saying, he said multi-stage build and distroless is the best way to do that. Oh, it's that Aditya. Yes, sorry. I think there's a couple more.
That's the one I did.
There's this one.
Do you have lessons learned from companies that adopted CHPS and GitGuardian tools? I do. There's one, I don't know if I can name them out loud, so I'm not going to. But they wrote a really awesome article that didn't specifically name it, but I talked to the team that did on SALSA attestation for their internal processes. And they say it was game changing because they spent 6 months in the process. SALSA is not something you just flip a switch and it's done. SALSA is an ongoing concern. It's something you have to keep doing. But they had to go through and talk to everybody that touched anything on the team and understand, how does your workflow actually work? We need to document it so it's reproducible. And they said that process showed them that, wow, we are leaking a lot of stuff into logs. We didn't even think about leaking into logs. So they started using GitGuardian to go and redact those things from the log level. And then they started realizing like, well, wait a minute, why are we using an image this size? Why are we doing this instead of that? Once they started putting the pieces together and thinking about it from a holistic security perspective. So I think I've talked to companies that do that. Again, I wish I had permission to say the name of that company out loud, but I don't think I do. But I've heard a lot of stories out there from the field like that.
Yeah, so from my end, like chips is a very new specification. Like I announced it at KubeCon EU. It is an open specification. It's not necessarily tied to Chainguard. It is open to external contributions. That being said, I would answer from like a Chainguard perspective. So what we find is people adopting Chainguard container images. They just reduce a lot of toil. So they spend a lot less time investigating CVEs. And there's also people working in regulated industries. They're often interested in things like FIPS images. If you don't know what FIPS is, be thankful. But people that need FIPS, they tend to be very interested in our FIPS images, and they've helped them accelerate their process to get towards FIPS.
Okay. And then Adrian Mouat with Docker containers. Yeah, we already answered that one. Okay, let's start live answer here.
Yeah.
Okay for scan at each step, but how it prevents 0 days when detected after periodic scan. Resident agent inside image. Like, well, the problem with the 0 days is 0 day. You don't know about them until you do. Until there's a CVE it's not known. But once there's a CVE, that's your camp. Like, how does that process work for y'all? Like finding the new CVEs and actually seeing, hey, what does this apply to for your stuff?
Yeah, you're absolutely right. I think there's a few things we can talk about there. I think the answer is periodic scan. Obviously, you can't catch a 0 day unless it's not a 0 day anymore. But a periodic scan is definitely a way to go. The other thing I would talk about is something that people. So Chainguard was started by ex-Google employees, and they talk about something called build horizon. And that's basically the idea that if a container or VM or whatever has been running in production for more than a set amount of time, I think in Google's case, it's something quite aggressive, like a week, but you can be longer than that. Even if there's no changes to the software that container or VM is running, they will take it, they will replace it with a newer version, a newly built version. The reason being that the dependencies, although the code for that application hasn't changed, the code and dependencies will have. So they want to always be running the newest version of everything. So that's a build horizon idea, and I think that touches on this. Yeah. Oh, the other thing was, like, if you're using sort of minimal images or like Chainguard images, and they just accumulate CVEs at a slower rate. So even if you're using an old Chainguard image, there should be less CVEs than an equivalent image.
Well,
How are we doing for questions?
Looks like we have answered everyone's question. So if anybody's got another question, we have time to answer it. We'll try do our best to answer. Other than that,
oh, there's an update. Did you see the update about the RMF?
Which one?
Raphael uploaded the. I think you maybe mentioned that. Actually.
Yeah, I did mention that. Yeah, over in the there. So yeah, once I saw the circles, like, oh, I have seen that before.
Besides Iron Bank and Chainguard are the other recommended sources for FIPS from clients or low or zero. Well, I'm not gonna. I mean, obviously Chainguard's the best one. I work for Chainguard. There is competition out there now. I still think Chainguard's the best way to go here, especially in terms of FIPS. I will let you do your own research there, though.
Rigosh asks, want to know more about the life cycle of containers. Yeah, it's actually a good question. The life cycle of containers themselves, like, is life cycle of all software in my life cycle of any piece of software. Like, it runs its life, you update it, you don't use an old one. I mean, the beauty of a container is that the update isn't really an update in the traditional sense that you're taking a thing that's running and moving additional parts, you're literally making a brand new image if you're doing it right, and dropping that brand new thing into a new container, a fresh start. So it's not update, it's redeploy. That's how I've always viewed it, but I don't know if you have other strong opinions on that, Adrian.
I'm sorry, I was looking at Miriam's question, so I wasn't quite ready. I think it's definitely interesting. I think that's a very wide-ranging question, so I'm not quite sure where to focus on, to be honest.
It's like everything else in the software, like it depends.
I do want to get back to Miriam.
Yes.
I don't
Sorry
want
about
to feel like, well,
back to it.
I think we did touch on it earlier. In terms of misconfigurations, I think you don't want your containers to run as root. It's arguably not a misconfiguration or much of a choice, perhaps. But in production, I really would try to avoid having containers running as root, just because if like an attacker gets in, then they're running as root, and if they get to if they manage to escape from the container, then they're running as root on the host. So that's, not running as root is definitely a good idea. So that's a number one I would look at. And I think I mentioned signing as well. That's maybe not a misconfiguration, but it's just sort of low-hanging fruit that I think a lot of people don't do and does help security. Catch them before CI/CD pipelines even run. Well, you can run the chips specification if you like. I would argue that would help. I'm not sure if you have any other suggestions, Dwayne.
It depends on what your CI/CD pipeline looks like, but it is possible to simulate your entire build process locally. There's a tool called Act that I was playing around with a little while ago when I was more in the CVE world side of things, experimenting that. And Act lets you run GitHub Actions locally, and you can just any tools you would normally build with that, you just run it locally, and then you have a local before you ever push that commit up. So that's one path. That is but then we're on additional levels of effort for the developer. Figuring out like what are the things that you're most concerned about, and enabling the developer with better guardrails. So if it's security, if it's secrets, we got you covered. That's what we'd love for you just to use ggshield and never push a secret out in the world ever again. But it's running those tools locally, making sure that you depend to the right digest.
There's Dagger as well. That's quite good at that sort of thing. Running basically the same as you would in CI/CD but locally. So I love
I forgot about that.
That's worth looking at.
Oh, that's from the guy that invented Docker.
Solomon, yeah.
Solomon's. All right. Well, we are almost out of time. Hopefully, we've answered your question that time, Miriam. Hopefully, we've answered everyone's question. Let's see, we got a couple of people left in chat here, and then Chainguard's. Phipps, thanks for that link. Okay, thanks, Miriam. So with that, we're going to call it quits. But Adrian, got anything else to leave us with here at the end?
No, I'm not sure. But please go check me out on Blue Sky, Twitter, LinkedIn, and feel free to ask me any questions or follow-up questions. And yeah, that's about it.
Like I say, this recording will be made available to everybody that registered. And thank you very, very much for being here.
Okay, thank you for having me.
Have a great day. Bye-bye.